In this video, we will be covering the 4.3 elimination method practice. Technically, it's practice number 1, even though it does not say practice number 1 on it. So this is all about elimination, and we're going to be using elimination through the guided notes. So once again, we included the flow map for you. This flow map works every single time. If you found a different way to multiply to get one of the variables to cancel out, that would be totally acceptable. But we use this flow map to help guide the students. So notice that we have these two equations in standard form. So if you use the flow map, we're going to look at the coefficient of 3, and we're going to make that negative. We're just going to do the opposite of one of the numbers. Then we're going to look at this coefficient, and we're going to keep it. So we're going to change one, keep the other. So negative 3 times negative 6x gets you a positive 18x. Negative times a positive gets you a negative 15y. And then equals negative 3. Don't forget to multiply all the way over. Then we do the second equation. So negative 6 times 3x gets you negative 18x minus 12y equals a positive 30. Now that we have these two equations, our third step of the flow map is to add them. When we add them, our x's are going to eliminate. So then we're left with negative 27y equals 27, because negative 3 plus 30 is 27. So then we are going to divide by negative 27. So we have y equals negative 1. Plug this back into one of the original equations. I will choose the first one. Instead of y, we're going to replace it with negative 1. So negative 6x minus 5 equals 1. We're going to add 5 to both sides. Now we have a friendly one step. Negative 6x equals 6. We need to get that x by itself. So then we're left with x equals negative 1. Notice that I have an x variable and I have a y variable. So that means I actually have an ordered pair. Ordered pair means one solution. So if I check my solution, I do in fact have the correct values. Now on the next slide, we're going to do basically the same idea. We're going to look at the coefficients of the x values. So I'm going to make negative 4 opposite. I'm going to multiply the first equation by positive 4. And then I'm going to keep that negative 7. Now, please use this calculator if you need to help. We have 4 times negative 7, 4 times negative 8, and then 4 times 9. Let me rewrite it so it's clearer for you. And that negative 7. So 4 times negative 7, calculator says it's negative 28. Don't forget the x value. Minus 32y equals a positive 36. Now my second equation, I'm going to multiply the bottom equation by negative 7. I'm going to multiply the coefficients first. And then the constant at the end. Now negative 7 times negative 4 is a positive 28. Write down the x. Negative 7 times 9 is a negative 63. Write down the y. And then all the way over, 7 times negative 7 times negative 22 is a positive 154. Now this becomes a giant adding problem. The x's go away when we add them. Then we're left with negative 95y. And then 36 plus 154 gets us 190. We're going to divide by negative 95. And we're going to get y equals negative 2. Now it's important for you to plug in the negative 2 into whatever equation you would like. I'm going to stick with the top one. Make sure when you're plugging in, you plug in the right value into the right variable. So this is going to get us a positive 16. So then I'm going to minus 16 on both sides. Now I'm going to get a negative 7. And then I still have that negative 7x, drop down my equal sign. And now I get to isolate the variable. So x is going to be a positive 1, because negative 7 divided by negative 7 is a positive 1. Let's confirm. Notice I forgot to write the negative 2. Now notice that I have my x value still, and I have my y value still. So that would get us an ordered pair, or a point on the line, or on the lines, on the system of equations. So that is why the answer is one solution. All right, for our third problem, we're going to multiply by negative 3 because we're going to make one opposite. And then I'm going to drop down the 5. If you wanted to do it the other way, that would be totally acceptable. So negative 3 times 5 is negative 15x. Negative 3 times 4y is a minus 12y. Please don't forget the variable. And then definitely be careful. Negative times a negative is a positive 90. So negative 3 times negative 30 is a positive 90. So then we have 5 times 3, which is 15x, minus 45y. And then definitely use a calculator for these bigger integers. We have 5 times negative 18, which gets you a negative 90. Big adding problem. We're left with negative 57y equals 0. Please don't let this fool you. We still have a variable, so we still have to do the one step. Now the nice thing about when the 0 is on top, that means your y equals 0. 0 is a number. Please don't forget that. We still have a variable and it equals 0. So now we get to plug that in. And then 4 times anything is 0, so it goes away. Now we're left with a one step. One step in this case, get to divide by 5, x equals negative 6. So negative 6, comma, 0. Let's confirm. And then one solution, because we got an ordered pair. Now lastly, slide number 10. Once again, we're going to multiply. Now this is a negative 4, so I'm going to rewrite the opposite as a positive 4. And then I'm going to drop down the 3. So 3 times 4x, or 4 times 3x is 12x. 4 times a positive y is a positive 4y, because 4 times 1 is 4. And then equals 40. Then we have negative 12x minus 6y equals 6. So the x's once again cross out. We're left with negative 2y equals 46. Some students are concerned when they get a big number like this or a very small number like this, but negative 23 is part of our solution. Now we get to plug that into our first equation. Now remember, positive times a negative is just a negative 23. So now we can do our friendly two-step. We're going to add 23 on both sides. And we're going to get 33. 3x equals 33. We're going to divide by 3. And we're going to get the x variable to equal 11. Notice that we had the variable, and then we had the y variable. So in fact, it is an ordered pair. We confirmed it. Ordered pairs mean it is one solution. So that's the end of the elimination practice number 1.